Michio Kaku is a renowned physicist, television host, and best-selling author and professor of physics at City University of New York. His latest best-selling text is called Physics of the Future: How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. He joins us tonight from Chicago. Dr. Kaku, good to have you on this program, sir.
Glad to be on.
Let me start with a couple of questions relative to news of the day about Japan. So we have another aftershock today on the anniversary of the initial earthquake and a tsunami. You have argued of late that we need to entomb this reactor that is still concerning so many in Japan and, for that matter, around the world. There are others who disagree with that approach. Your thoughts first?
Yes, first of all, the reactors in Japan are stable in the same way that a ticking time bomb is also stable. It wouldn't take much to light the fuse. A 6.6 earthquake like what happened today in Japan, a pipe break, an overpressurized containment vessel, anything could set it off, in which case we would have another Chernobyl, 3 times the magnitude of a Chernobyl accident. And that's why I say that we should, as a last resort, prepare to entomb the reactors in concrete, sand, and boric acid.
There are folks who say that that's too risky. Your response?
It's risky to allow radiation to constantly go up into the atmosphere. The main criticism of this approach of entombing it is that it would cost too much, involve too many resources and people. But think of the cost of having all the crops impounded by the government, all the milk being thrown into the river, people's livelihoods destroyed. Every day, more radiation seeps out, causing panic in China, Korea, and even in the United States. The ultimate damage could be billions of dollars extra, when entombing the reactor would only involve a few $100 million.
To your point now, Professor Kaku, how concerned should we be here in the States about radioactive water, since we keep reading every day about this activity in the ocean?
Radioactive milk has already been found in the United States at the level of about 3 picocuries per liter. That's roughly the legal limit. However, it is very, very low. No need for panic. And in fact, all of us have a piece of Chernobyl in our bodies going back in 1986. Back then, we had an accident much larger than the Fukushima reactor accident. Cesium iodine from the Chernobyl reactor accident went around the world many times, and everyone on the earth has a piece of Chernobyl in their bodies, but it's very tiny, too small to cause much damage.
How has this radioactivity in Japan impacted the debate about nuclear power and nuclear safety in this country? Put another way, have we advanced the conversation? Have we taken this issue seriously enough, given the warning that we have courtesy of Japan?
This is a game changer. You realize that in Germany, they've canceled a whole series of nuclear power plants and basically have thrown in the towel with regards to nuclear. In the United States, President Barack Obama is poised to initiate a new generation of nuclear power plants in the United States, and the debate is already starting in the halls of Congress. Now, in Japan, they've made the Faustian bargain. Faust was this mythical figure who sold his soul to the devil for unlimited power. The Japanese have made that Faustian bargain because they don't have coal, oil, or hydropower. However, the United States has a choice. And this is definitely going to spin the conversation, spin the debate, as we begin to grapple with what could happen in the United States, because we also have reactors on earthquake faults. We have the Indian Point nuclear power plant north of New York City, where I live. And in fact, it's right near the Ramapo fault. And in fact, the NRC, the Nuclear Regulatory Commission, calls it one of the most hazardous reactors in terms of earthquake damage. California has 2 nuclear power plants near the San Andreas Fault, Diablo Canyon between San Francisco, Los Angeles, and also the Sanofra reactor between San Diego and Los Angeles.
Since we're talking about what may or may not happen in the future, let me now segue, that is, and connect this conversation to your new book about the physics of the future. When I got a chance to go through this, I was stunned and fascinated and scared all at the same time, and quite frankly excited by some parts of the book about what you predict will be the kind of lives that we'll be living in this country and the world, for that matter, by the year 2100. Just to list a few that got my attention: the internet, you argue, and our contact lenses, life expectancy 150 years, cars that will drive themselves, courtesy of GPS. How will physics define our future?
Well, take a look at the internet. In the next 10 years, computer chips will cost about a penny. That's the cost of scrap paper. The internet will be basically for free, and it will be inside our contact lens. When we blink, we will go online. When we see somebody that we don't recognize, our contact lens will identify who they are, print out their biography in your contact lens, and translate, if they're speaking Chinese, into English with subtitles as they speak. The demand for these contact lenses will be enormous. The first people in line will be college students taking final examinations. They'll be able to blink and see all the answers right there in their contact lens. Artists will be able to move their hands and create fantastic works of art. We'll be living in Star Trek, where we have the holodeck, or the movie The Matrix. Architects will love it. They'll be able to rearrange towers and architectural wonders right in their contact lens. And also the military will love it, because soldiers can see the entire battlefield right there in your contact lens. Tourists will love it, because they'll be able to see the ancient ruins of the Roman Empire resurrected for them in their contact lens as they walk through the streets of Rome. This is a game changer.
Beyond contact lenses, tell me more about your look into the future vis-a-vis physics.
When we look at now the mid-century, not just 10 years into the future, but maybe 40 to 50 years in the future, we'll have direct mind contact with computers. We physicists know that the brain is a milliwatt transmitter of radio. We have computers that can decipher much of this gibberish coming from our brain, and we could then use that to control computers. So already we can take stroke victims who are paralyzed, cannot communicate with their loved ones at all, hook them up to a laptop, in which case they can now surf the web, do crossword puzzles, do video games, write and answer emails, even though they are totally paralyzed. And so the point of the book is that by 2100, we'll have the power usually reserved for the gods of Greek mythology. Like Zeus, we'll be able to move objects around mentally, and we physicists are now making this possible right in the laboratory. This is not science fiction. This is something that we physicists are doing now. Like Venus, we'll have near-perfect bodies, ageless bodies, because right now scientists are beginning to regrow organs of the body as they wear out. We can already grow bladders, windpipes from your own cells. In 5 years' time, we will probably grow the first liver from your own cells. So alcoholics out there can take note. And then, like Apollo, we'll have chariots that take us in the sky. We'll finally have flying cars before the year 2100. And like Pegasus, we'll be able to recreate life forms that don't walk on the surface of the earth. We'll even have zoos of extinct animals, animals that have been extinct, resurrected using genetics. All of this before the year 2100.
As I mentioned earlier, it's exciting and at the same time scary and fascinating. You mentioned a word a moment ago in your response. The word power came up once in your response to my question, and I'm reminded, as you well know, that power corrupts. So all these things, as exciting as they may be about the future as we head toward 2100, somebody is going to use this for ill. Somebody is going to use this power to corrupt communities. So what's the negative? What's the danger you see as we move toward 2100, given these things that physics will allow us to actually do?
Well, I've interviewed over 300 of the world's top scientists to get the most authentic picture of what 2100 may look like. And these scientists tell me that there are two trends in the world today. One trend is toward more democracy, and no two democracies have ever warred with each other in the past. Think of every single war you've learned about since you were in grade school. Not a single one was between two democracies. And the internet spreads democracies. Take a look at what's happening in the Middle East, for example. But there's another trend that you point out. The other trend is toward chaos. We have the trend toward nuclear proliferation, biogerms. What happens, for example, if a government decides to take the AIDS virus and weaponize it and make it airborne? Airborne AIDS could literally wipe out 99% of the human population, including the people who created airborne AIDS. And so we have to realize that science is a double-edged sword. One edge of the sword can cut against poverty, illness, disease, and give us more democracies. And democracies never war with other democracies. But the other side of the sword could give us nuclear proliferation, biogerms, and even forces of darkness. Terrorists may even get a hold of this technology.
All that said, given that you are a physicist tracking this work and doing some of it, you lean toward being more hopeful about the future or more frightened by the future?
I tend to be more optimistic about the future. Some people are a little bit afraid about the future because they see all these gadgets and gizmos coming down the pike and they think they're too old to learn all this new stuff. But eventually they begin to realize, hey, some of this stuff is useful. Growing new organs of the body as they wear out, extending the human lifespan, what's not to like? And then in the last phase of this transition, people begin to realize, hey, I thought of it already. This is something that everyone can enjoy. And so, yes, there are dangers, but only dangers if people don't understand where technology is taking us. And that's why I wrote this book. I'm not a science fiction writer. I'm a physicist. These are scientists who are making the future in their laboratories. And this book, it consists of interviews that I've done with 300 of the world's top scientists who are inventing the future now in their laboratories.
Finally, just to make sure I read this correctly, I'm told from my research at least that you had two heroes when you were growing up as a child. Make sure this is right. One, Albert Einstein, I think I get that, and the other, Flash Gordon.
Yes, I had two passions when I was a child. First was to learn about Einstein's theory and help to complete his dream of a unified theory of everything. That's my day job. I work in something called string theory. I'm one of the founders of the subject, and we hope to complete Einstein's dream of a theory of everything. But I also love the future. Watching Flash Gordon, watching science fiction, but then I began to realize something. To understand the future, you have to understand physics. Physics of the last century gave us television, radio, microwaves, gave us the internet, lasers, transistors, computers, all of that from physics. The next century will be even greater. And that's why if you understand physics, you understand computers, you also understand biotechnology, nanotechnology, and they are going to be the engines of wealth and prosperity into the next century.
So for all this brilliance and intellect, we can thank Flash Gordon. Michio Kaku is the author of the new text, Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. Dr. Kaku, good to have you on the program.
I'm a scientist, and when we try to look at something, we try to quantify it, we try to rank it in terms of levels, give a numerical scale. But when you look at consciousness, you realize that there are over 20,000 papers written on it by theologians and ministers and psychologists. Never in the history of science have so many devoted so much to produce so little. And so being a physicist, I say, well, how would a physicist approach a solar system, an atom? First, we describe the electron in space. That's the first thing we do. Try to understand planets and motions in terms of space. Then we try to understand their relationship to other electrons, other planets, stars, for example, creating solar systems. And then stage 3, we go forward in time, and we make predictions about the future behavior of planets going around stars. And so when you apply the same methodology to consciousness, you realize that there really are three stages of consciousness. Consciousness that understands our position in space, consciousness which understands our position with respect to other people, emotions, social hierarchy, politeness, etiquette, and third, predicting the future. And so I say that there are three levels of consciousness. Now, I give a definition of consciousness, something which eludes some of the greatest philosophical works, I think. I read a number of treatises on consciousness, and they never define it. I give a definition in one sentence, and that is, consciousness is the process of creating multiple feedback loops to create a model of yourself in space with regards to others and in time in order to satisfy certain goals. Alligators, for example, would be at stage one. At level one, they understand their position in space with regards to prey. The back of our brain, for example, is the most ancient part of our brain, the reptilian brain. No, way in the back of the brain, the medulla, the cerebellum, balance, for example, in a car accident. You would sustain injury here, your sense of balance is thrown out, territoriality, hunger. Then the center part of the brain develops when you're an adolescent. That's the monkey brain, the brain of social hierarchies. That's when children have to learn politeness. That's when they have to learn social etiquette and the social hierarchy and control their emotions. And then the last part of the brain to develop is the front, the prefrontal cortex, and that is the thinking brain, and that differentiates us from the animals. Animals have level one consciousness. They understand their position in space. Monkeys have level two. That is, they understand their relationship to other monkeys. But only humans have level three consciousness, which is understanding tomorrow, the future. We daydream, we scheme, we plan. Animals don't do that. It's all instinctual for animals. And then a scientist says, well, this scale is very nice, but what is your unit? Your unit of consciousness. My one unit of consciousness is a thermostat. One feedback loop that allows you to monitor the temperature in a room, because it senses its position with regards to temperature. A flower may have 10 or so, because it has to monitor temperature, humidity, water, sunlight, so on and so forth. And then by the time you hit a reptile, maybe 100 different kinds of feedback loops. By the time you go to a mouse, perhaps thousands of feedback loops. And then we, as humans, we're the only ones who see tomorrow. If you have a pet, like a dog or a cat, you can teach it many tricks except understanding tomorrow.
So then, where would you put numerically our consciousness? And
well,
how exactly do you get to that number? Because you're talking about measuring consciousness, and you mentioned those 20,000 papers. Most of them, or many of them, say you cannot really measure consciousness. You cannot even identify, some of them say, the brain structure that it's associated with, arguably. What would you want to say about that?
I think we can rank up the scale and measure the consciousness of anything, even robots, even extraterrestrial intelligence, animals, dogs, cats, and pets, on the number of feedback loops. For example, a thermostat would have 1 unit, a flower would have 10 units, but think of a crocodile. Crocodile has multiple feedback loops because it has to understand its position in space and then its prey, understand the behavior of the prey. And by the time you go to monkeys, it's even much larger. Monkeys have to understand emotions. They have to read body language. They have to understand their position in a social hierarchy, coalitions, who's your friend, who's your enemy. Things that are very, very complex are involved in monkeys. By the time you reach a human, the total number of feedback loops involved in predicting the future is enormous.
Yeah, I understand that, but my concern here is that we kept kind of a relative scale. So human relative to a monkey, monkey relative to alligator, alligator relative to a flower.
Right.
But do we get an absolute measurement? Because, I mean, isn't that what science is all about, to have a mathematically precise, exact number in the end of the day?
Right. So in other words, I would give a test to a human to rank their level of consciousness. It's not an IQ exam. That's the first thing you think of an IQ exam. But when you follow people with high IQs over 20, 30 years, you find a lot of marginal people, petty criminals, people on the margins of society. IQ tests do not strongly correlate with success in life. However, there is one characteristic.
Criminals.
However, when you look at a criminal, you realize that safecrackers, even though they may have low IQs because they flunked grade school, they may understand the future of a bank robbery much better than the police.
Exactly.
They can outwit the police because they can dream up scenarios more realistically than the police can. So here's my, quote, IQ test. And that is to put people in strange environments and have them calculate realistic scenarios. Now, the Air Force understood this. Long time ago, the Air Force gave IQ exams and found that they were not very useful for understanding how good pilots are in war. They gave them another test. Let's say you're stranded behind enemy lines. Calculate the total number of escape plans that you can devise. And they found that people who have, quote, low IQs were very good at seeing the future. And people with high IQs did not necessarily see many escape plans like the others. And that's what I'm saying. The number of realistic scenarios you can compute for a given situation, being stranded on an island, or being stranded behind enemy lines, robbing a bank, that correlates to me much better with our level of consciousness than an IQ exam. And again, all of this is measurable. We can put this on a scale, including robots. If my scale is correct, then even robots can be ranked by consciousness. I would say that robots are at level 1. They understand their position in space. They have the intelligence of a cockroach. Asimov, one of the most world's advanced robots, I interviewed the creator of Asimov, and he admitted that, Asimov has insect-like intelligence. That's an exact quote from the developer of one of the most advanced robots on the planet Earth. Now, at MIT, they're trying to develop some emotional robots. That would be the beginning of level 2, and maybe even a little bit of level 3, because robots can predict the future in one dimension. They can predict, for example, airflow on an airplane wing, but that's about it. We can predict the future in multiple scales. Throw somebody on a deserted island, let them survive, put them behind enemy lines. All of a sudden, you realize that you have to have a full complex of common sense notions about space, time, and other people in order to escape behind enemy lines.
So I want to come back to the topic of robots in a little bit later, but for now, can you talk a little bit about the relationship between the brain on the one hand and consciousness? How does it arise in the brain, where exactly, and how does that whole process work?
Well, historically, we had something called dualism, where the spirit, the soul, was different from the body. Then in the last 50 years, we had a little bit of neuroscience, where we began to realize that the brain is wetware. Wetware that runs software called the mind. So we began a unified theory so that the mind is software running on the wetware of the brain. But now we have the next level of evolution, and that is the connectome. President Barack Obama and the European Union want to dump $1 billion to create the connectome, a map of all the neural circuitry of the human mind. So one day we'll have 2 discs. We'll have a genome and a connectome. One which has a map of the genes of our body, and the other one, all the neural pathways of the mind, which contains emotions, memories, sensations. And in some sense, we're going back hundreds of years into the past. We are now separating the body from the mind by having the genome and the connectome. And realize that when you die, in some sense, the connectome and the genome live on. And of course, does that mean that you are immortal? Well, to paraphrase Bill Clinton, it depends on how you define you. If you are nothing but wetware running software, then when you die, hey, that's it. Sorry about that, folks. You're gone. But if your connectome and your genome survive, in some sense, a part of you live forever.
I'd like to stay away from the Clinton-esque definitions on my show, generally speaking, but they're very funny, I admit. Now, so tell us a little bit more about what your take is on, for example, the hammer of Penrose theory of quantum consciousness. Because there are many ideas about what consciousness is, how it arises, where. One of them is actually a colleague of yours, Dr. Sir Roger Penrose, very famous physicist, together with Dr. Stuart Hameroff, whom I previously interviewed on this show. So their theory is kind of very controversial and ostracized generally in the field. In fact, during my Global Future 2045 conference, I was kind of surprised to see Ray Kurzweil, who is generally a very sort of even person, kind of come up very strongly against the theory and saying, we know that's wrong, straight out. So what do you think and what do you make of that model?
Well, Penrose, of course, is a very well-known, well-established physicist at Oxford University. I think he's onto something, but perhaps there's less than meets the eye. First of all, the question is a computer deterministic? That is, once you push the button, the outcome is known perfectly. The answer is yes. A computer is nothing but a bunch of transistors. You push the on button, and you get an output. Then the question is the human brain deterministic?
Exactly.
Are we programmed, or do we have free will?
Exactly.
And that goes to the whole question of philosophy, religion. Are you responsible if you are a mass murderer? Why do we put people in jail? Why do we punish people? Our entire society rests on the question of free will. If we are a bunch of transistors, then there is no free will. So in some sense, I disagree with the hardcore determinists who say that we are nothing but a bunch of transistors masquerading as neurons that is totally deterministic, that one day we can model with a machine. I think that we do have some degree of free will. However, the free will is different from the free will of Penrose and other individuals that have written about the subject. For example, if I have a motion picture of a Hollywood movie, everything is deterministic. I know the beginning, I know the end. People in the movie could say, I have free will. I am the master of my destiny. But we know we hit the play button. Mm-hmm. And the play button means that everything is scripted, meaning that this conversation is scripted.
Yes.
That means that the outcome of this conversation is also scripted. I don't believe in that for several reasons. First of all, there is the Heisenberg uncertainty principle.
Yeah.
If I have two Earths and create them 4.5 billion years ago and then run the play button, 4.5 billion years later, if I have twin Earths, will they both evolve humans? And the answer is probably no.
Not necessarily.
Probably no, because of Heisenberg uncertainty principle. So quantum mechanics does play a certain role in the human mind. Now, if you take a look at trying to model a neuron, realize that neurons are leaky. They're messy. They're not digital. They're not just on and off. Sometimes they leak. They have all sorts of deficiencies. Neurons are not totally deterministic. Mm-hmm. And I think that the narrower a neuron is, the more leakage you get. And these are quantum mechanical effects. Mm-hmm. So I disagree with Penrose into thinking that that's why we cannot build a robot with human-like intelligence. I believe that we will, one day, create robots with near human-like intelligence that are indistinguishable from humans, passing the Turing test. So I would disagree with my colleague Roger Penrose. I believe that we will one day have a robot that can pass the Turing test. However, I also believe that there are quantum effects. Mm-hmm. Otherwise, we are totally deterministic.
In the brain, you mean?
In the brain. Mm-hmm. Neurons leak. They have quantum mechanical effects that manifest at the ion level because, of course, you have the transport of ions across neurons that enable it to fire. Mm-hmm. These are small effects. So for the most part, the brain looks deterministic. But I think ultimately there is free will. Ultimately, we are masters of our destiny.
You know, there's so many fascinating things that you said there that I'm going to start grabbing one by one, a few of them. But first of all, let's stay with free will for a second, because I'm a philosopher, and that's a very important topic to me.
Right.
But also, I want to push you a little bit more, because some of the most famous physicists in the history of physics, from Newton to Einstein, were hardcore determinists.
Right.
And you kind of break away seriously with that tradition, and you're saying that we do have free will. How do you feel about that, staying against names like Newton and Einstein?
Well, first of all, the universe is not deterministic because, sad to say, Newton and Einstein were wrong on this question. We have quantum mechanics, which is the most successful theory of all. It's successful to 1 part in 10 billion, making it the single most successful theory of all time. However, it is based on uncertainty, meaning that things cannot be totally deterministic. So this conversation, the end of this conversation cannot be totally determined. We are not actors acting in a film that is already made and is being shown in a Hollywood movie theater by simply hitting the play button. Mm-hmm. That's not the way reality works. And so I think there are quantum effects. However, I don't think they're huge. Some people think that because of quantum effects, we have free will just like the ancients imagined. I don't think so. I think to a large degree, you can't predict the future behavior of the brain. And when some criminal says, it's not my fault, my brain made me do it, I say that, well, in some sense, yes. In some sense, criminals are blameless. I still think we should put them in jail and throw away the key for some of them because they're dangerous people. I think there are dangerous people that should be locked up, perhaps for the rest of their life. Mm-hmm. But is it their fault? No. Because in some sense, their brain is largely deterministic, and it means that it's true, their brain made me do it. Their brain is defective. For example, you can brain scan people who are serial murderers and pathological killers. Mm-hmm. Some of them, you can see that their nucleus accumbens, their pleasure center, lights up when they see images of people being tortured. They love the idea of torturing other people. But does that mean you put them in jail? Only if they commit a crime. Once they commit a crime, you put them in jail. Are they at fault? No, I don't think so, because the word fault is a human word that has no scientific justification. Blame, fault. These are words that humans have used to describe other people's behavior they don't like, even when they're, quote, not at fault because their brain made them do it.
Mm-hmm. You know, that's very fascinating, and that kind of connects with my next question on the brain here, which is in two parts. The first part is, do you think that the brain is properly a classical computer then in that sense?
No, it's not a Turing machine. The Turing machine, you have inputs, outputs, and a program that massages the inputs. Mm-hmm. However, the brain has no windows. The brain has no software. It has no programming. It has no CPU. It has no Pentium chip. It has no subroutines. The brain doesn't have any of the standard characteristics of a Turing machine or a digital computer. The brain is a very sophisticated neural network. It is a learning machine. It rewires the resistance of all its connections upon learning any task. And that's why for the last 50 years, I think we were on a wild goose chase trying to create a digital computer that can mimic the human brain. The human brain is a learning machine. It's quite different from a digital computer.
And the next step there is brought to us by the research of Dr. Norman Deutsch from the University of Toronto. And in a book called The Brain That Changes Itself, Dr. Deutsch speaks about what he calls neuroplasticity, and about the fact that in his view, the brain is not a machine at all, and it has to be understood on its own terms, because if you accept the idea of the brain as a machine of any kind, then that leads to what he calls neurological fatalism, which is not able to explain how the brain is actually able to grow and heal itself. And then he talks about the sort of the feedback loop between the thoughts that can actually change your brain and also, of course, the brain changing your thoughts.
Well, I think the brain is a machine. It's a biological machine, very sophisticated, and we have not yet been able to even mimic a fraction of the capabilities of the brain. But I think the brain is a machine.
But does it have neuroplasticity?
Oh yeah, it can rewire itself. Neural networks change themselves all the time. The question is, does it have a soul? That's an additional question, okay? A biological machine may have a soul, and being a physicist, I say that all theories have to be tested, they have to be reproducible and falsifiable. So, if people believe in soul, then we have to measure it. And people have tried. When people die, scientists have tried to measure whether or not the weight of a body changes when you die. And we find no visible change. So at a certain point, the idea of a soul is, in some sense, untestable, not reproducible, not falsifiable. Not necessarily wrong. It just means it's outside the boundaries of science. And so, of course, the brain is a biological machine. It's a machine that rewires itself. It's a machine that is not a Turing machine. Mm-hmm. The brain is not a standard Turing machine. The brain has no programming. Where's the programming? Where's the Windows? Where's the operating system up there? There is none. Because it does one thing much better than any Turing machine, and that is it learns by rewiring itself. So the brain is a biological machine. The question is, does it have a soul? And my answer is, I don't know. I'm a physicist. I only work with things that are testable, falsifiable, and reproducible. And until someone can give me an experiment that allows me to test and reproduce and falsify a theory of soul, I'll say that the jury is out.
Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, we're going to summarize some of the top stories in science. Our lead story is perhaps one of the strangest stories to come across our desk in, well, maybe decades. First of all, people have always looked for signs, any kind of sign of intelligent life in the universe. Some people look for flying saucers. Some people look for, well, alien crash flying saucers and little dead aliens. However, astronomers look for some kind of structure,
some kind of structure in outer space that could only be artificial. Well, this news story has now created a frenzy on the internet. In fact, if it's correct, and we don't know if it is correct or not, it could be the biggest story since the discovery of fire or the invention of the wheel. And that is an alien megastructure that's perhaps even bigger than Jupiter may have been sighted by the Kepler telescope. Let me explain. First of all, the Kepler telescope has been orbiting in outer space for quite a while, for several years, and it's detected over 1,000 planets circulating other stars in deep space. And how does the Kepler satellite do this? It looks for shadows of planets that then go right across the surface of the mother star, and starlight begins to damp as a consequence. In other words, the planet eclipses the mother star, and starlight diminishes by maybe 0.5% or 1%. Well, this is where the magic occurs. Back a few years ago, the Kepler telescope identified a star about 1,500 light years from the Earth, such that starlight dimmed not just 0.5% or 1%, but by 15%. This is humongous. This had never, ever happened before. And a few years later, it damped once again by a factor of 22%. This is unheard of. Whoever thought that starlight could diminish by that much by an object which seemed to be, well, not natural? In some sense, maybe it was artificial because it didn't seem to be shaped like a circle. Everything in outer space that we see, large objects anyway, are basically round. However, this object may not be round, and its orbit is highly irregular. Well, this sent astronomers scrambling to the blackboard, trying to figure out what the hell is this object. Well, we'll say more about this in a few more minutes when we get right into the news of the past week. As I said before, the lead story today concerns an alien megastructure. Now, let me explain. When scientists look for signals of intelligent life in outer space, they don't look for little green men, they don't look for flying saucers, they look for two things at least. First is radio signals that obviously imply intelligence. Radio signals that are regular rather than simply being static. Second of all, they look for alien structures, megastructures. If aliens are really out there and they're advanced, they may be able to assemble an object perhaps as big as a planet. Or they might be able to play with natural phenomenon. In other words, starlight would be affected by their very presence. So far, we have found neither. I repeat, we have found neither. No evidence of any radio signals exhibiting any regularity or any message, and no alien megastructure until now. Now astronomers are scratching their head. They're wondering what the hell could be causing this. As I mentioned earlier, there's a star about 1,500 light years from the planet Earth, and starlight does indeed dim, just like the Kepler telescope has verified. That's not a big deal. However, the dimming of starlight is usually on the order of 0.5% or 1%. However, here, the starlight dimmed by a factor of 15 to 22%. This is gigantic. This is off scale. Think about it for a moment. An object bigger than Jupiter that seems to be artificial. Now, let me explain. We scientists, when we talk about civilizations in outer space, rank them by energy, type 1, type 2, or type 3. A type 1 civilization can harness planetary energy. For example, all the energy that strikes their planet from the sun. They could, for example, control the weather. A type 2 civilization harnesses the energy output of an entire star. For example, the Federation of Planets in Star Trek might be a type 2 civilization. And then there's type 3, galactic. They control the galactic space lanes. And what do we have here? We have an object that is apparently, who knows for sure, exhibiting Type 2 technology, specifically a Dyson sphere. Now, what is a Dyson sphere? Freeman Dyson, physicist at Princeton, knew that there was this ranking of intelligent civilizations by energy output. And he reasoned that if there really was a Type 2 civilization, its energy consumption would be so great that they would literally control the energy output of the entire star. Now, how can you do that? You could do that by building a shell around the mother star, which then absorbs all the starlight from the star. Now, you can imagine, a civilization comparable to ours cannot do such an incredible feat. We can barely create cities, let alone an object much bigger, for example, than Jupiter. So a Type 2 civilization would have a signature. They would be able to play with starlight, so that light from the mother star would flicker. It would be perhaps irregular, or perhaps the star would simply disappear totally. Well, eventually, the Dyson sphere itself would heat up by the second law of thermodynamics, and it would get hot. So it would start to glow in the infrared. Well, given that fact, scientists have actually looked for Type 2 civilizations in outer space. They should at least be able to radiate infrared radiation. And so scientists have taken this very seriously and looked for evidence of a Type 2 civilization. What did we find? Nothing. We find no evidence of any radio emissions from intelligent species. We see no evidence of infrared planets in outer space. Well, that's why this new story is very intriguing. In 2011, the Kepler satellite first found evidence that something spectacular was happening with this star. Starlight was dimming by 22%. That is off scale. Now, as Carl Sagan once said, remarkable claims require remarkable proof. This means that you simply can't announce to the world that we found it. We have found evidence of intelligent life in outer space. No, it doesn't work that way. Scientists are cautious revolutionaries. That is, they are very cautious until they are finally convinced that what they are sitting on is earth-shattering. Then they become revolutionaries. So scientists, being conservative revolutionaries, notice this star making this tremendous change in intensity. So scientists begin to look at possible candidates. First, meteors. Well, meteors are a possibility, but they're very tiny. This object is perhaps even bigger than the planet Jupiter. So cross off meteors. What about another planet? Well, this object is even bigger than Jupiter. It would have to be huge. What about comets? Same thing applies with comets. That is, they are small objects. Well, one by one, they crossed off all possibilities until they were left with the last possibility, which is an alien structure. A structure built by a civilization perhaps thousands of years ahead of us. Now, what are we on this cosmic scale, and how long will it take for us to attain this kind of status? We are Type 0 civilization. That is, we get our energy from dead plants, oil and coal. We are nothing to brag about. Type 1 is perhaps 100 years more advanced than us. Type 2 is perhaps a few thousand years ahead of us. And Type 3 is perhaps 100,000 to maybe 1,000,000 years ahead of us. So if a civilization had the power to create some kind of sphere, some kind of solar collecting device comparable to the size of Jupiter and beyond, then we are talking about a Type 2 or a Type 3 civilization. And so scientists begin to say, oh my God, what could possibly rival the energy of a Type 2 or a Type 3 civilization? Now, there are exotic possibilities. These possibilities are extremely rare, but since we are dealing with an unprecedented phenomenon, we have to consider them. One possibility is that we have a highly irregular solar system. A solar system in which many planets can seem to coalesce in front of the mother star because of their random orbits or strange orbits, eccentric orbits around the mother star. This would help to explain why it was irregular, and also perhaps looking at the object, you would see multiple planets, and therefore starlight would dim more than just 1%. Still, it stretches the imagination to believe that you can have an object that can dim starlight by 22%. Well, another candidate is some kind of collision between comets. Maybe this object is actually quite closer to the Earth, not so far away, not orbiting right around the mother star, so it gives the impression that it's bigger than it actually is. And, as a consequence, perhaps this object is really not the size of Jupiter. Perhaps it's a comet storm, a collision of multiple comets. That is also a possibility that cannot be ruled out. Any other possibilities? Well, if you can think of one, perhaps you can have your name in lights if it turns out to be correct. In other words, we really don't know. At the present time, we are really clueless as to what natural phenomenon can account for an object that big with that particular shape and that particular characteristics. Then the next question is, what's the next step? What do you do after you find evidence that there could be an alien megastructure in outer space? The next thing to do, which wouldn't cost that much, is to focus our radio telescopes to look for any hint of intelligent life. Realize that we've been doing this, but only for a few thousand stars. Believe it or not, there are 100 billion stars in the Milky Way galaxy. And how many of them have actually been analyzed in detail? Well, you'd be shocked. Just a few thousand. A few thousand out of 100 billion stars that exist in our solar system. So we have a long ways to go before we can begin to say that we've analyzed even a significant fraction of the number of stars in the Milky Way galaxy. And what do we look for? We look for any signs of regularity. I mean, after all, the aliens don't speak English. The aliens don't use the same mathematical symbols as us. So how would we recognize a signal from an alien civilization if it were staring at us in the face? It would be regular rather than random. That is perhaps the only clue that we would have that we're literally listening in on I Love Lucy from outer space. So, any sign of regularity, any sign that is non-random, that would be the signal. And now we're going to focus our radio telescopes, instead of looking at thousands of stars in the solar system, we'll look at this particular star to see whether it has any regularity in its messages. Next, what do we do about it? Do we call them on the telephone and say, hey, here we are, brothers in the galaxy? Nope, it doesn't work that way. This star is about 1,500 light years from Earth, meaning that it would take about 1,500 years for a message to go from the Earth to this star. And once they receive the message and they send back a message from outer space, it would take another 1,500 years for us to detect it. So in other words, a two-way conversation would be basically impossible. It would take 3,000 years for a message to go from here to there and back. But perhaps the biggest criticism of this approach is, what happens if they don't use radio at all? Perhaps they view radio as archaic. I mean, for example, do we use smoke signals? Do we use smoke signals to communicate here on the planet Earth? Of course not. I mean, smoke signals are a sign of desperation when you have advanced electronics. But you have to admit that the message on a smoke signal does, in fact, travel at the speed of light. For example, let's say they use laser beams. If they use laser beams, they would be collimated. They would be in the optical frequencies rather than the radio frequencies. And basically, we wouldn't know. we wouldn't even know that we were staring at a message right in front of our eyes because we would not have the instruments that are focused in on the optical frequencies, that are focused in on the characteristics of laser light. And so simply looking for signs of intelligent life by analyzing its radio signals is kind of pathetic. Sorry about that. So a two-way conversation with them would be practically impossible. Then the next question is, well, if they're that advanced, that is thousands of years more advanced than our civilization, then why don't they visit us? Why don't they come in, announce their presence, and give us the benefit of their advanced technology? Well, as I've mentioned before, if you're walking down a country road and you see a bunch of ants in an anthill, are you tempted to go down to the ants and say, I bring you trinkets, I bring you beads, I give you nuclear energy, take me to your ant queen? Or do you have this politically incorrect urge to perhaps step on a few of them? Well, that's the problem. You see, we are so arrogant to believe that an alien civilization, thousands of years more advanced than us, would be dying to land on the White House lawn to announce their existence. Nope, not a good idea. And then we have the position of my colleague, Stephen Hawking, who says that why even bother to try to make contact with intelligent life in the universe, because chances are they're going to be evil. And if they're evil, the first thing they may want to do is take us over. I mean, an example he cited was the conquistadors. What did they do to the Aztec Empire? They destroyed it. They plundered the Aztec Empire. An empire that took thousands of years to rise from the forest was essentially wiped out within just a few matter of months. They could do the same thing to us. And so it's dangerous to make contact with intelligent life in outer space. So says Stephen Hawking and others. My particular point of view is that, well, we should not advertise our existence to aliens in outer space. But, hey, we've been admitting Isle of Lucy of our own for the last 50 years into space. My personal attitude is that we should not go out of our way to advertise our existence in the universe. Of course, during the days of the Pioneer spacecraft, they actually put a medallion on the spacecraft giving the coordinates of the planet Earth, giving a description of life on the planet Earth, and any alien which picked up this medallion could easily triangulate and easily figure out where we are located. And then what's the alien response going to be? Well, are they going to say, lunch? Gee, lunch just occurred in the form of a Pioneer spacecraft. Let's go for lunch. Or are they going to say, these are intelligent creatures. Maybe we should make contact with them. I think more than likely, if they pick up a medallion or sense that there is life on the third planet from our sun, they would say, interesting, but so what? They have nothing to offer us. We have nothing to offer them because they cannot even begin to understand our technology. So for the most part, we would leave them alone. And then the next question is, well, if you really do have a Type 2 civilization, probably has been probing neighborhood stars for years looking for intelligent life, what is the best way to search for intelligent life in the universe? Well, I'll be blunt. Sending Captain Kirk on the Starship Enterprise is perhaps the worst way to search for intelligent life in the universe because there's simply too many stars. You spend billions of years hopping from one star to the next trying to analyze 100 billion stars in the Milky Way galaxy, of which perhaps 1 billion actually are Earth-like suns. So what is the best way for them? The best way for them to search for intelligent life in the universe is through robots. That is, self-replicating von Neumann probes. Probes that make copies of themselves. Starting from one probe, you could put it, let's say, on a moon, which is stable. It makes 1,000 copies of itself from moon rock. They scatter, land on 1,000 other moons, and then create each one 1,000 more probes. Well, from one, you get 1,000. Then from 1,000, you get 1,000,000.
a billion, trillion, quadrillion. And then in 5 generations, just 5 generations, you get quintillion of these space probes shooting out into outer space. This means that perhaps on our moon, on our own moon, there could be evidence of a previous visitation. And that, of course, is the basis of the movie 2001.